This lesson is a pretty short one where we talk about the different types of graphs that you've learned about in the past. And there are two types of graphs. There's qualitative and quantitative. Qualitative data, or as it might make more sense logically to call it categorical data, it consists of labels or what you might consider non-numerical entries that can be separated into different categories. So this would be like when you first learned how to do bar graphs and you took a poll of your classmates and you saw, what pets people had or what their favorite color was. That's qualitative data. When you have qualitative data, you don't usually find the mean because it doesn't really make sense. Like, what's the average pet that somebody has? I don't know, like turtle, like how do you find the average of pet types, or how do you find the average of, favorite colors? But you can do measurements for things called quantitative data. Now, it might make sense to you that quantitative data comes from the word quantity, or well, it doesn't really come from it, but they have the same root word, quant, which is things that are numerical. So we're talking numbers that represent counts or measurements. So this would be like the height of people in your class, or the number of people absent, on the team, things like that. So let's look down at example 1, and we have to just say whether it's qualitative, meaning it's about categories, or quantitative, which would be about numbers. Pause the video and see if you can figure out what they are on your own before I give you the answers. Okay, in letter A, we've got prices. Prices are clearly numerical, so that's quantitative. We'll skip B right now. Letter C is song lengths. Those are numerical measurements, so that's quantitative. And letter D, zodiac signs. Those are non-numerical categories, so that would be qualitative. Now let's go back to B, because my guess is that some of you put quantitative because of the phrase numbers. But even though jersey numbers are numerical, they're kind of like the labels that people put on the shirt. It doesn't make sense to compare them, and you can't really measure jersey numbers. Like you wouldn't say, what's the average jersey number on the Patriots, right? Like, who would do that? So it doesn't make sense to do those numerical calculations with the jersey numbers. So even though it represents a number, it's more like the label on their shirt. Now, you can have quantitative and qualitative data come from the same source. Like, for example, if we're talking about back in the day when you made bar graphs, right? You could say, what pet do you have, or what pets do you have? Or you could say, how many pets do you have? So you see the difference in that question is very slight, but it changes it from being from categories into quantities. So it's not like one is better than the other, but there's a difference. So an example of like that would be how much do you earn per hour at your job? That's specifically quantitative that you could ask a student. Or you could say, what is your occupation? And so that would be qualitative. For a house, you could say how many square feet of living space is in the house. That's a numerical piece of information. Or you could say, what city is your house in? And that's qualitative. That's categorical. This chart goes over all the different types of graphs that you learned all the way back in the day of pictographs, right, where you just kind of used pictures to represent quantities, and then you've progressed all the way to some new ones, right? We did scatter plot earlier. I know you did box and whisker plot recently, like in years past. All these other graphs, histograms. Look at how much knowledge is in your brain right now. All right, let's move on to the next example. So what we're going to do now is use that chart to help us decide what graph we need to use to best display the data. So I'd like you to pause the video and look at examples A and B and just say what graph you think is best used for these tables. My first choice for letter A would be circle graph, because the circle graph shows how parts relate to a whole, so we can see how the amount of each eye color compares as a whole group in terms of the survey. My runner-up choice would be bar graph, because you could just make bars represent the color, because this is categorical data. So I would use a bar graph and it would just go to these numbers. My choice for B would be double box and whisker, where you have like one box and whisker plot on top of another box and whisker plot to see how they compare with each other. I would use it to show how, the speeds vary on one interstate versus the other. You could also use a double histogram. A histogram is used for intervals of data, so here's a good point. A histogram is used for quantitative data, and a bar graph is used for qualitative data. You would not use them for each other. A bar graph is very specifically for categories, and histogram is very specific for numerical ranges. So we're going to do these in class when I see you next, because when you do a circle graph, you need a protractor and you need, like a compass. So we're going to do all that stuff together. So I'm not going to have you make the graphs right now like the question says. We're going to do that in class. I don't normally read paragraphs for you, but this is worth reading with you. Just as there are several ways to display data accurately using graphs, there are several ways to display data that are misleading. Now, side note, misleading doesn't mean wrong, it just means that it's used to make you feel a certain way. So, let me continue. A misleading graph is a statistical graph that is not drawn appropriately. This may occur when the creator of a graph wants to give viewers the impression that results are better than they actually are. Below are some questions you can ask yourself when analyzing a statistical graph that will help you recognize when a graph is trying to deceive or mislead. So, not trying to get too political on you, but depending on which news source you listen to, it's going to cater to the listener. So, you might have two ways of presenting the same exact information, and one news source is going to spin it one way and the other news source is going to spin it a different way to cater to how they want to present the news. It doesn't necessarily mean that either one of them is necessarily wrong, but it's just twisted in a way to make you feel something. So you can read those questions on your own. Let's go down and let's look at example 3. So I'm going to pause for a second so you can read those questions. So we have to decide how each graph is misleading, and then we have to explain how someone might misinterpret it. So in graph A, if you notice, there is no breakdown here. It goes straight at 15,500. And if you look at this first line, you see that's like a little over 2 boxes. And then this other one is over a little over 5 boxes. So visually, it looks like this 2010-2011 bar is more than double this 2007-2008. But if you look at the numbers, 16,500 versus 18,000, it's not that much more. It's certainly not double. So the fact that it doesn't have a break is misleading. So I'll tell you that bar graphs can't have a break because of this specific reason. So the thing that makes it misleading is that the y-axis scale does not start at 0. How might someone misinterpret this graph? Well, they might think that the tuition is going up significantly faster than it actually is. Okay, when you're ready, let's look at letter B. And if you look at letter B, it does have a break, which is okay because line graphs are allowed to have a break if there's no data. But what happens is you'll notice that it's going up by very tiny increments, and then it switches what it's going by. So first it goes by 0.02s, and then it goes by 0.01, by hundredths versus 200ths. So they change the scale. I wrote the y-axis scale is tiny, meaning it's going by tiny intervals and also not equal. How might someone misinterpret it? Well, it looks like it goes up really fast right here, but that's actually not the greatest increase. The greatest increase, if you look at the math, is actually 2009 to 2010. So that would be how someone would misinterpret it. I summarized that to just say someone may calculate the wrong rate. All right, we're going to create those graphs when you come to class, and if you have any questions, let me know. See you then.